December 9th, 0240, 53 kilometers north of Fort McMurray, Alberta. The temperature reading on the site board says minus 38 Celsius. A Caterpillar D11T has been running since the start of the graveyard shift. Its tracks are already caked with frozen oil sand, that dark, bituminous material sitting at a 7.4 on the Mohs hardness scale. Nearly as hard as sapphire, triangular, abrasive, relentless. The blade is pushing. It has been pushing since 2200, and it will push until the relief operator climbs into the cab just before dawn. And then the next operator will push again. This is the Athabasca oil sands, the largest surface mining operation on Earth. And before the shovels load, before the haul trucks roll, before a single barrel of bitumen begins its journey to market, the bulldozer is already in the ground, doing the work no other machine can do first. Tonight, we go inside the operation that moves Canada's oil sands. The machines, the conditions, the decisions made in the dark. If you enjoy watching real heavy machinery in action, bulldozers, excavators, and the machines that build the world around us, hit that like button. And if machines like these fascinate you as much as they fascinate us, consider subscribing to the channel. But we also want to hear from you. Have you ever worked around heavy machinery, operated equipment like this, seen machines like these on a construction site? Tell us in the comments. Many of the best stories in this community come from the people who have actually lived these moments. Now back to the story. But to understand how this operation unfolded, we have to go back. Not just to the beginning of the shift, back to what this place actually is. The Athabasca oil sands stretch under more than 141,000 square kilometers of northeastern Alberta, beneath the boreal forest, beneath the muskeg and the peat bogs, beneath the frozen river valley that Alexander Mackenzie described in 1787 as bituminous fountains he could not reach the bottom of with a 20-foot pole. The reserve is staggering. Alberta's government has estimated approximately 173 billion barrels of economically recoverable bitumen in the region, roughly 75% of North America's total petroleum reserves. But the oil doesn't come out of a well. It is locked inside the sand. The Athabasca oil sand is composed of approximately 83% silica sand, 10% bitumen, 4% water, and 3% clay. On the Mohs hardness scale, where diamond is a 10, oil sand registers 7.4. The individual grains are triangular and angular. They don't roll past metal surfaces. They cut into them. Only the area north of Fort McMurray sits shallow enough to surface mine, with overburdened depths of less than 75 meters across roughly 3,400 square kilometers. That is the zone where the bulldozers work. That is where everything begins. Before the shovels, before the crushers, before the processing plants that separate bitumen from sand. The blade goes in first, and the machine behind that blade has to be engineered to survive an environment that will try to destroy it before the shift ends. The Caterpillar 11T is the machine most associated with Alberta's oil sands overburden operations. First introduced as the D11N in 1986, the year Caterpillar launched its largest production bulldozer. The line has been continuously refined across 4 decades. The D11T arrived in 2008, powered by the Cat C3-2 ACERT engine producing 850 horsepower. Operating weight sits at approximately 229,800 pounds. That is more than 104 metric tons, making it one of the heaviest production bulldozers on the market. The blade options define what this machine can do. The standard 11U blade holds 45 cubic yards of material per push. The carry dozer variant, with its deep curved blade geometry, carries nearly 58 cubic yards per pass, a volume that would fill a standard shipping container in a single blade load. The elevated drive sprocket, Caterpillar's signature high-drive triangular track system, keeps the drive components above the ground line, away from the abrasive material. This single engineering choice is the difference between a machine that survives oil sands conditions and one that doesn't. At the heart of the D11T is a load-sensing hydraulic system refined through decades of mining feedback. The tilt cylinders allow the operator to angle the blade independently, directing force precisely where the ground demands it. In frozen overburden, where one section might be solid ice and the next section fractured rock, this precision is not a preference. It is a production requirement. The current D11 also integrates CAT MineStar technology, GPS terrain mapping, automatic blade height control, and options for semi-autonomous operation, bringing computing power into a machine that already represents the physical limit of what a bulldozer can be. The CAT D11T does not work alone. Across Suncor, Syncrude, and other Athabasca surface operations, coordinated fleets combine multiple machine types to move overburden efficiently. One of the machines operating alongside the D11T, particularly in high-volume downslope pushes, is the Komatsu D475A. The current D475A-8 variant produces 899 horsepower at an operating weight of 248,240 pounds. Where the CAT D11T leads in blade precision on hard, irregular frozen ground, the Komatsu D475A-8 brings sustained mechanical force through its automatic lock-up torque converter, a system that keeps the drivetrain fully engaged during long downslope pushes where a conventional converter would slip and lose efficiency. The overburden removal cycle follows a fixed sequence. Water trucks go first, suppressing ice-conditioned dust on haul roads, managing surface conditions on the bench approaches. Motor graders pre-cut the surface. Then the bulldozers move in, typically in pairs, and sometimes 3 or 4 machines working the same bench face simultaneously, beginning the systematic clearing of the overburden layer. Each mining bench stands approximately 12 to 15 meters high. The bulldozers work the face from the top, pushing material down to create a clean cutting line for the electric shovels or hydraulic excavators positioned at the bench base. A precise bench face matters enormously. Irregular faces left by poor dozer work create loose, fractured material that excavators cannot load cleanly into the 400-ton haul trucks waiting in cycle. Even a 2-minute extension of the loading cycle, repeated across dozens of trucks across a 12-hour shift, adds up to real production loss. The bulldozer pass sets the pace for everything that follows. Winter temperatures north of Fort McMurray regularly drop to -40°C, and occasionally beyond. At that temperature, hydraulic fluid thickens to a consistency that restricts actuator response time. Steel contracts. Rubber seals lose elasticity in ways that only become apparent when a machine is under load. Engine cold start procedures take 10 to 15 minutes, even with block heaters running. And the tracks carry frozen oil sand packed into every joint from the previous shift. These are not stock machines. Oil sands bulldozers run with Arctic-grade hydraulic fluid, pre-warming systems, reinforced track seals engineered for abrasive silica intrusion, and blade cutting edges made from hardened steel alloys specifically formulated to resist the angular quartz grains of the oil sand matrix. Those quartz grains, making up 92% of the sand, don't yield. They abrade. Track link assemblies in oil sands operations can see wear rates 2 to 3 times higher than comparable hard rock mining environments. Final drives, the heavy gear reduction assemblies that transfer engine power to the sprockets, require inspection on intervals measured in operating hours, not calendar months. The machines do not return to a central shop at the end of a shift. Mobile service units, diesel-powered repair trucks carrying hydraulic wrenches, oil evacuation systems, thermal imaging equipment, and critical parts inventory drive out to the machines on the bench, in the dark, in the cold. A D11T at full production burns approximately 100 to 130 liters of diesel per hour. You stop the machine, you stop the mine. The mine cannot afford to stop. Intelligence. The CAT MineStar command system available on current D11 models allows dozer operations to be monitored, directed, and in select configurations, semi-autonomously controlled from a remote operations center kilometers from the active bench. GPS terrain mapping guides blade height automatically. Overcut protection prevents the blade from going below grade. Volume tracking delivers real-time data on cubic meters moved per bench per shift. Suncor, one of the largest oil sands producers, has conducted trials of fully autonomous haul truck fleets. Semi-autonomous dozer trials have run on Canadian mine sites. The trajectory is clear, but automation has not emptied the cab, because the Athabasca oil sands do not behave consistently. Buried ice lenses, hidden pockets of frozen water within the overburden, shatter unpredictably under a loaded blade. Permafrost transitions create zones of sudden ground softening where a machine rated for solid frozen material encounters conditions that approach quicksand. Buried boulders, clay pockets, gas seeps. None of these appear on terrain maps until the blade finds them. An experienced operator reads these signals in the feel of the controls, in the pitch of the engine note, in the way the machine's momentum shifts before the instruments register anything. That knowledge cannot be programmed. It is not in any service manual. It lives in the people who run these machines through the long dark shifts of an Alberta winter. The equipment will keep getting smarter. The conditions never will. By the time the first gray light touches the Athabasca mine floor, the D11T has already moved thousands of tons of material. The bench is prepared. The shovel is loading. The haul trucks are in cycle. This is not a dramatic operation. It does not look dramatic from a distance. It is methodical, repetitive, relentless. But it is how Canada's oil sands work, and they work every single day, every shift. Through heat and frost and the grinding persistence of a material that was designed by geology to resist being moved. Behind every barrel of bitumen that leaves Fort McMurray at the very start of the chain, there is a blade. There is a track. There is an engine pushing 850 horsepower into ground that doesn't want to give way. That is not a detail. That is the foundation. If this story meant something to you, consider subscribing to Machine Geek Canada. This channel exists because people who appreciate these machines keep coming back and sharing their experiences. And if you've ever worked around heavy equipment, bulldozers, excavators, demolition machines, tell us your story in the comments. What machine did you operate? Where did you work? What was the toughest job you ever faced? Many of the most powerful stories come directly from the people who have lived them.